Let me introduce Dr. Ilya Avdeev, who is an engineer at College of Engineering at UWM, and he's quite gracious to give us this appointment. And we will start his opinion and critique on the project we are doing for the last 3-4 years. So Ilya, you're on.
Thank you, Narendra. Thank you, Ed. Good to be here.
Me too. Thank you for coming.
Absolutely.
So you've had some time to look at this and think about it. Where I guess we'd just like to hear your thoughts on where this might go.
Yeah, I've had a little bit of time with this. When did we start? 2010? Either 2000, late 2009 or early 2010. 2010. That was the first time I met Narendra, and I remember he came to UWM and we had a little meeting with several people involved in energy generation, energy transmission. And Narendra pitched his idea. He rolled out the blueprints of his ideas. He gave us the CD with the video that they shot at Berkeley Beach. And I got excited right away. I thought it was amazing idea. And I've never seen anything like that.
And your students have been using it as a teaching aid as well as trying to work on the design?
Yes. So what we did is we put together a team of students that would take his initial design, his initial prototype that is in front of us, and try to redesign it and maybe try to make it a little bit more efficient, and also use conventional technologies rather than wood, something more robust, more manufacturable. Also with a little bit of spin towards being able to manufacture it very cheaply in the third world countries. So we use PVC pipes and things like that. And the student team enrolled in a class, a product realization class, which I teach, and they had the entire semester to take an idea and make a working prototype and then test it. So that was the beginning of the journey.
Okay.
And Narendra, of course, generates more ideas that we can process, and that's fantastic. He keeps us on our toes, that's for sure.
Well, Narendra, you want to talk to us a little bit about your ship, rocking ship and trolley idea?
Yeah, right. Both of the ideas I'm quite intrigued and feel a little bit different direction than the first one we made. This is works really well, and it can develop into larger scale and so on. And ultimately, my vision about this is it can mount on a harbor wall, and so one side is the waves coming in with more power, and the other side is totally quiet, so it can be housed on the harbor wall and link them all together with the one shaft, or all machine can be generating individual power, and then it can be connected to electricity. So you don't know yet, but that engineering people can decide which one is more feasible, economical.
So you're talking about this sort of an item, but a roll of maybe hundreds or more along a seawall or along a breakwater of some kind.
And then either we can, this shaft can be connected with one to the other, and create a whole machine linked together, mechanically linked together. Or, as I said, mentioned, that each one can generate its own electricity, and then collectively they can go out on the land. So that is a little issue, has to be ironed out.
That's where the engineers come in,
Yeah.
how to do that.
And this thing I see between these and other two is this one is still in contact with the water, which is harsh water, corroding water, salt, and so on, and harsh weather it takes. The other one, it can be mounted on the ocean liner or big boat, big sailboat with power that what you call
Almost any kind of a decommissioned ship.
decommissioned large ocean liner, either oil tanker,
Something with
or
flat
cargo,
backs.
oil tankers or cargo. When it gets decommissioned, but it is yet has a lot of life there to float. We are not worried about moving it from one place to another in the world, but it can be in one place and anchored and made it rock. So it kept again the waves coming, and it can generate water, generate electricity, and it can be to the
Sent to shore like
shore
by
line
cable.
And the idea in there is that, in my mind, is ocean is a solar battery fully charged all the time, 24 hours every day, and if they will need to recharge, it's always charged, and this is kind of getting the power from.
Yeah.
But I know that you're very interested in supplying power to small villages, places where they don't have a grid. Something like we're talking about here, maybe a giant ship parked offshore wouldn't work, but maybe 20 or 30 of these might. I mean, it seems like it's very adaptable.
Yeah, but there's definitely potential for scalability. That's why I like this idea a lot. But you can either make it power a village, or maybe even power one house, or you can make it power entire town if you have a big hull parked in the wake zone somewhere in the port or somewhere else. The hull idea is, I think, unique in the sense that you can create a product that is contained. You don't have to deal with EPA and other agencies in terms of installing something on the coast, which creates potential problems for deployment of these machines. You just have a hull that is anchored by the shore and a cable. And another benefit of this technology is that it uses waves. It means that it's close to the shore. It means that transmitting energy is not a problem. Most of the wave energy relies on buoys that are deployed away from the shore. And then you need cables and other things, and that makes it very expensive. And the initial cost of deployment is really high. With these, you just purchase a hull pocket connected to the.
And you can tow it anywhere and set it up at anywhere there are waves.
Yeah.
So a lot of changes probably would have to be made to our electrical grid over time. We're talking about smart grids now and microgrids, and doesn't it seem like this sort of power would fit into that scenario quite well?
Yeah, I think so. I think it's very complementary to other alternative energy sources, solar, wind. Coastal energy becomes more and more a player in the area. I think it would probably still make sense to maintain array of batteries on this hull, so you can store the energy that you harvest. So in a sense, the hull will become a little microgrid, with energy storage capabilities, and then you can integrate it with other grids. But the biggest problem is conversion. If you can efficiently convert wind energy to electric energy, you call it.
Yeah, I want to mention one thing. I'm a sculptor, not an engineer. But in my whole life, I always like to tinker around and get some ideas out. And sometimes I do it a little bit and then cache it, and again some new idea coming. So I'm keeping myself busy beside my sculpture work, which is kind of using as an outlet to relax and things like that. But so after I started this, some of the friends who knew that I'm spending my time on designing something unusual, so people started to send me clippings of what is going on in the world in this subject. So I'm not really expert on knowing everything which is happening now. I have some clippings coming. From those clippings, I've thought of one thing that what makes difference between this, my three projects, and what is going on in the field by some other big companies and engineers. One thing strikes me is that they're working with really harsh environment and trying to win that nature, which is very harsh and powerful. And here, my feeling is that we are working around knowing the nature, and rather than fighting with it, we are working with it, and try to understand how we can use that energy without risk of the danger on our side to fight and try to conquer. Here we are working with it, and that's how I see it. And those whole idea is that our project will be completely sealed inside the hull and totally protected. The hull has been designed for few thousand years, and now come to the conclusion that we have very dependable floating system which can float forever almost. So we are using it what has been invented. So I'm saying it, we are not trying to invent a new wheel, but trying to find the new use of the unique use of the invented wheel which already exists.
That's correct. I think the biggest challenge with this technology is to understand the nature of the body of water that you're using to harvest energy. So what is the wake or wave pattern? Because when you design it, you use it as your input of energy that you convert. And with solar energy, for example, it's pretty predictable. You have a lot of solar arrays in the sunny areas of the world, where almost every day is sunny. You know what's the length of your day.
The math is easy. You know the efficiency of your
the math is
equipment.
easy. Yeah. The wind is a little bit trickier, so you're already entering a lot of unknowns. And with water, it becomes, I think, even more tricky because there's so many factors that will affect it. if you, for example, park your hull in a busy harbor, the weight will depend on the traffic. So it can be a good thing or it can be a bad thing. If you just park it in an open body of water, then you rely on the weather, the moon cycle. So it is tricky. I think most of the research in this area should be focused on getting this solid data on the weather and the water conditions that can be used by engineers as a starting point.
And that was something we really never talked about or thought about, was wakes. We were just thinking of natural wind-generated waves, and the idea of having using wake energy that's awesome, because no matter where there are big boats, there are big wakes.
Absolutely.
You know, whether the wind's blowing or not.
And this is the kind of technology, because of its scalability, a small prototype can be built and tested on Lake Okachi, where you have areas with lots of wakes, and not the same no wake area, but tons of wakes. Something like this can be tested.
The problem for us is understanding what the cost is versus the return.
Yeah,
how difficult is that to figure out? What, you know, first of all, you maximize the efficiency, and then you can get some output, and then you can discover those numbers. How difficult is that really to? It seems like quite a challenge to.
It is challenging. Yeah, it is absolutely challenging, and it's not easy theoretically. We can obviously have a good estimate of the efficiency of the mechanical system that we're designing, but estimating the power output is not easy. So our power output will determine your how much it would cost, because we will know how much it takes to build and maintain, and then if you know how much energy you're producing, then you can calculate how much
what your return on investment is
per watt or kilowatt, and then you will see how it falls into the bigger picture, you know, other energy sources. But power output, again, this is the most tricky part.
So it really requires electrical engineering, mechanical engineering. You need to bring in people who know about waves and weather.
Yeah. You probably would need to bring people from the College of Freshwater Sciences, people who deal with the lake. You would want to bring maybe climatologist or somebody from mathematics who is dealing with weather. You would want to bring maybe civil environmental engineer.
So you need really a very diverse group to actually bring this to use.
Yeah, this is a multidisciplinary task, which one particular discipline cannot tackle on its own. So I mean that's what makes it exciting for me. And I had actually a meeting this week in the College of Freshwater Sciences, and there are people who are interested in doing new things, and I think we can actually start the collaboration with them using this project as a kind of catalyst. Because I was thinking we have several kind of points of contact with them, things we do or want to do, but this might be one because we already have done some work, and there are people who do work with underwater robotics. There are people who do work with measuring different things in the lake using buoys.
So they're very familiar with the environment?
Absolutely familiar with the environment. They have a research ship that they take out and service the buoys and deploy things around. So they have a lot of interesting things. That ship can be used as a testing ground. You set up one of the rocking systems on deck as the ship goes. Another thing that I was thinking is you might want to have this system to generate auxiliary power on the ship. You have a ferry or something else, or a container ship that spends months in the sea or almost every day in the sea. They have to recharge their batteries. Why
Sure.
not have their own contained power generation system? And if it's a ferry and you generate a lot of power, you might use that power to charge electric vehicles that are on that ferry, going from Wisconsin to Michigan.
What a good idea.
I mean,
You get to your destination and you're charged up and ready to go.
so,
I can see you have been thinking about this. You have a lot of ideas.
I have another project that deals with electric vehicles, so I'm always thinking about how do you charge them. Because the range is the biggest issue right now. You don't get a lot of range.
Mhm.
So you try to charge everywhere and you try to charge fast. You cannot charge fast right now. The battery technology is not there yet. But you will be.
Mhm.
And
So, how you're imagining of approach or putting a proposal to the higher level means higher level people involved. So it's a lot of work to be done to
Yes.
bring somebody, some
Yeah.
outside player would come with money
yeah.
to start. So how we can approach
So there are different strategies here, and I'm not sure which one would be the most efficient. So one strategy would be treat it as a research project, and then there's the whole methodology and process of acquiring resources to conduct this research. Mostly writing proposals, applying for grants, and agencies like National Science Foundation, Department of Energy, EPA.
Mhm.
Maybe applying to some grants on the state level, since we live by the lake. Maybe there's some money there, but I'm not sure about that. So that's one way, and it's usually a long way. The time constant is very large, and it has a small chance of success, about 10 to 20% funding rate. So you have to prepare yourself for a long haul in that direction. Another way would be to try to do it from a commercial point of view, which would mean try to make a product that people will buy. And if you approach it that way, then it's a totally different funding mechanism. Then you're basically looking for investors, or you're looking for people who will buy the product if you can make it. So if you would want to go that way, then the first step would be building a prototype, because you really need to test it.
A working prototype.
You need to take it out in the water
Mhm.
and get the data and then output the energy output that you can get out of it before you start writing a business plan or a business model. Ultimately, the only number that people will look at would be how much each watt of energy will cost.
Mhm.
Even, I don't know what that number will be, but there are other things that are important. Things like you can use this in areas where you cannot use wind or solar, and it's deployable, and those are the benefits. So they should outweigh the other cost, or maybe, maybe it's not as efficient as wind, or maybe it's more efficient. And then, if you approach it like a business and you have a prototype that gives you some idea, then you start discovering your market or your customer. Who will be your customer? Who will buy it? And that probably would break down into different segments depending on the size of this. So we were talking about the powering a village, right? So then you probably are dealing with humanitarian organizations that would probably buy this as a deployable power generation system in areas of disaster. Actually, Hurricane Sandy showed that it doesn't have to be a village; it can be an island of Manhattan where you can use it. So, state, city, local, federal government might acquire this. FEMA might acquire this as one of the.
Something you could have in a shipping container, get there, get on it, and deploy.
And in the water, generate power. Maybe you want it to be auxiliary power for ships, then you have to talk to people who manufacture ships or people who operate them. Because if you can deploy it after market, once the ship is built, that's fine too. You can definitely talk to military. They want power all the time. You take any fleet, they spend a lot of time at sea and they need power, so you might use it. Then you can think of maybe make it for someone who lives on a lake, would buy somebody who has a lakefront property and looking for auxiliary power. So then it becomes small, compact size, something new.
Remote research stations where they don't get power.
Remote research stations. Now we're talking about buoys and things like that. Offshore drilling. Another market. So as you can see, there's lots of applications. But then you have to discover them. You need to talk to them and find out whether they need it or not. But you want to show them something. You want to show them some success.
So in this scenario, it's a big investment up front to build a working model that actually produces. But then that's when you have something to show people, you have numbers, something to sell. Before that, it's just an idea.
Exactly. There's this kind of common wisdom that when you want to become a millionaire, or you think your idea worth lots of zeros, the 6 zeros that makes you rich, or 7 zeros, whatever number of zeros, is actually in the ability to execute your idea. And the idea is just a multiplier of those zeros. So if you have just an idea, it's just a number, relatively small number. But the ability to execute, that's what puts it into the category.
Well, zero. After 3 zeros, my mind cannot comprehend.
Right. And it also depends on the currency, right? It's like a rubles, then it's worthless. There are ways to acquire funding and sources for this small prototype work. And that might be a path to take. I think it has potential, especially if students are involved. It opens up a whole new world of funding that is only dedicated to students. Make sure that they do something meaningful. And there's a couple of programs I already mentioned. National Collegiate Innovators Inventors Alliance. They have a grant, annual grant. It's called E-Team Competition. E-Team meaning entrepreneurial team. And they want to see multidisciplinary teams work on something that can become a business, but it has to be a technological product. And it has to tackle either healthcare issues or issues relevant to the third world population. And that fits perfectly. Our prototype in the class was actually geared towards that market. That's why I wanted to make it out of PVC pipes and make sure that the bill of materials is
locally
available and affordable. So that is one way. And I think the whole idea is very interesting project that might resonate very well. Because it doesn't have this huge hurdle of deploying it on shore, which is difficult. And another kind of parenthesis, potential problem I see with deployment on shore is if a hurricane comes or tidal wave and can just wipe out the whole system because it's so what's the word I'm looking for?
It's vulnerable.
It's vulnerable. Yeah. And you don't want to over-design it. It has to be very nimble and efficient and light, and that makes it weak against the power of nature. A hull idea is just fantastic in my mind.
And if a hurricane is coming, you can tow it into the harbor.
Absolutely.
Or out of harm's way.
Absolutely. So I would like to pursue this hull idea. I would like to team up with the College of Freshwater Sciences and have a team of engineers and students from College of Freshwater Sciences, and maybe team up with someone who understands the climate a little bit. But ultimately, with the goal of making, you already made a scale prototype.
Yes.
Make it on a scale where you can actually take it to the lake, to the active wake zone, and test it.
So now you have to build a boat.
So after we finish all this video of all three ideas put together in one package, how easy or how difficult it is to give the final presentation and show it to our chancellor?
It's not difficult. We can organize, well, meeting is easy to organize. It's absolutely.
Yeah. Can we maybe schedule a meeting with him, or three of us to go and present in their office, or
I would bring
here?
Yeah, I would bring. I'd like to bring maybe a few more people who would be interested. I'm thinking Tom Concy. I mentioned he's a professor. He has dual appointment in freshwater sciences and mechanical engineering. He's a biologist by training, but he does underwater robotics. And, he would certainly have some good ideas in terms of implementation.
Can you be instrumental to make a meeting?
Yeah, I can organize it, and we can even have our new dean of engineering, Jared. He must have some ideas, and also he just joined in September. He probably never heard about this project, so it would be nice to put him on the map and see what he has to say. But I'm confident we can make a prototype. The product realization course I teach, the fee is $7,500. If there is a fee behind it, there's somebody who is interested to sponsor it, you'll have a working prototype in 3 months. And it's guaranteed. That's the goal of the class, to make a working prototype. So that's probably the cheapest way of getting it done. But there are other ways. And that grant I mentioned, the NCIA grant, team grant, it's $25,000 for a team. So then you can take your initial prototype to a really good level. And, then you can have, business students involved. But also Startup Challenge, you have an student Startup Challenge. The little program I go around with a couple of other people. We encourage students to launch their businesses in technology field. So, and we give each team $10,000 to build a prototype and create a business model in 1 year. So if you think that you can just have a team of students working on that and try to launch a business, would you be the advisors, mentors, co-owners, whatever you come up with? We can find these students for you, and they can apply. And the application will be out in a couple of months. By the summer, we will know who will sponsor for the next year. And then they get $10,000, and then they will actually go through a very rigorous process of getting the business on the ground. That might be actually not a bad idea. So.
It would be good to have a bunch of energetic, bright young minds working on the project.
And as a matter of fact, our original, right now we're sponsoring 3 this year, and they're all over the engineering map, the projects. For the next call, we're adding an extra track or challenge, which will be mobile apps. So students who want to develop mobile apps and create a business around it, they will apply. We'll have the general technology track, which is hardware, and then we're thinking of having a clean energy track, which is the whole perfectly. Because clean energy track has interesting implications. The reason why we even started thinking about it is because state has a competition in green energy. It's a business plan competition. If you win it, you go to national competition. All of it is sponsored by the Department of Energy. If you win that one, you get $500,000
Wow.
towards.
That's a prize.
Yeah, and even state has good money. So we were thinking that we would like UWM student to compete in those. But right now we don't have the critical mass. So creating a track would tell our students that there's definitely a path that they can take. And I see this as one of the very strong candidates to actually win the track. Obviously there will be people with some solar power ideas and others, but this one is so ahead already in development that this can be a really good project. So if you're interested about thinking in that direction, I can give you way more details on the Startup Challenge, how it works. But maybe we add it to the conversation when we meet with Dean and Chancellor.
Ending here?
I think we've covered a lot of ground. I think we really, we're good.
Thank you very much.
Thank you very much, Ed.
Thank you.
Always a pleasure.